Hello friends, good morning. Today I am going to discuss about the topic regarding the P block element of the chemistry of class 12th. Okay. So this in this topic I am going to discuss only about the group 13 and group 14 elements, and it is a quick review or the revision of the chemistry of group 13 and group 14 elements. Okay, so without any delay, let's get started. So before I start, I will recommend you to subscribe my channel and press the bell icon so that you can get notified when the new videos come on the on my YouTube channels. Okay, and keep watching and don't forget to subscribe. So the first one is the group 13 elements. So what is the group 13 elements? Its electronic configuration is ns2 and np1. That means its outermost orbit is totally your half unfilled orbital of p. Okay, its oxidation state, that means the boron and the aluminum shows the oxidation state of +3 only, while the gallium, indium and thallium shows the oxidation state of both +1 and +3. Further, due to the inert pair effect, as we move down the group, the stability of the +3 oxidation state decreases while the hydrogen oxidation state is increases. So here you can find that the oxidation state also decreasing. Sometime it is also going on increasing. Okay, so oxidation state maybe fluctuate in case of the p block elements, and the we can going to discuss about the inert pair effect. What is the inert pair effect? It is the reluctance of the s electrons of the valence shell to take part in the the bonding. There may be some mistake. It arises due to the poor ineffective shielding of ns2 electrons. That means the s orbital electrons are shielded. Okay, and the valence shell is by the intervening the d or the f electrons. So the inert pair effect increase down a group. So you have to remember the things. The inert pair effect is increase down a group. While we go on a group, down a group, the inert pair effect is going on increasing, and thus the element present in the lower part of the group shows the low oxidation state, which is 2 unit less than the highest group of oxidation state. Okay, so this is the inert pair effect. After that, the halides, all the elements of group 13 except titanium forms the tri-halides of the general formula mx3. Okay, where the x defines the halide group like the fluorine, chlorine, bromine, iodine. Okay, these are the halide groups, and m be maybe some your metallic or some. Okay, okay. So boron trihalide exists as only the monomers, whereas the aluminum trihalide exists as a dimer. Okay, you have to remember the things. Nature of the trihalide. So what is the nature of a trihalide? The trihalides of group 13 elements have only 6 electrons in its valence shell and have the strong tendency to accept a pair of electrons to acquire the near inert pair configuration. So trihalides of the group 13 elements behave like a Lewis acid. Okay, so the borax, what is the borax? Its symbolic formula is Na2B4O7 dot 10H2O. Okay, when going to discuss about the orthoboric acid, it is H3BO3. It is a weak monobaric acid. Okay, but we can say the diboron, it is B2H7. It is a dimer of BH3. Okay, you have to remember all the things. After that, going on the group 14 elements, what is the configuration? Here the configuration also changed than the groups in the 13 elements. It is NP2. Okay, NS2 occurs as before, but here the changes is NP2. That means the 2 electron in the p block elements. Okay, p orbitals, not the p block elements actually. But the oxidation state of group 14 elements, so the +2 and +4 oxidation state. As we move down the group, the stability of the +4 oxidation state go on decreasing, while of the +2 oxidation state go on increasing. Okay, while down the group it occurs. So after that, the catenation is the property of self-linking of atoms of an element through the covalent bonds to form a straight or branched chain. as in the carbon we have seen in the organic compounds. Okay, the ring of the different size are called the catenation. Among the group 14 elements, carbon shows the maximum tendency for the catenation. So here I have already discussed the carbon shows the catenation property. As we have go down the group, the tendency of this to show the catenation property also decreases. So while we going while we going down the group, the catenation property also going on decreasing. The formation of halide, that is tetrahalide, all the members of group 14s form the tetrahalide, but in case of group 13 element they form the they form the yes, they form the trihalides. Okay, like mx3. Okay, but in case of the group 14, here they can form the tetrahalides, that is mx4, where x belongs to the all the halide groups like the fluorine, chlorine, bromine, iodine. Okay, and the stability also the tetrahalides decreases as we go move from carbon. Then the dihalides. So all the members of group 14 dihalides form as the formula of mx2, where the x belongs to the halide groups. The stability of the dihalide decreasing as we go move down the groups. Here you have seen that the while you go move down the group, the your um, stability of the dihalides are increasing. Okay, but in case of tetrahalide, it is stability to tetrahalide are going on decreasing. The formation of the oxide after that. Okay, all the elements of the group 14 form the two types of oxide, that is monoxide and dioxide. You have to remember the thing. What is monoxide? The all elements of the group 14 for the monoxide of the general formula MO. Okay, and the dioxide, all the elements of the group 14 form the dioxide in the general formula MO2. The dioxides are prepared by the heating the elements of oxygen except the lead, which forms the lead monoxide. Okay, except lead, all the other elements form the dioxide. CO2 is a monomeric linear molecule, hence it exists as a gas, while the dioxide of all the other elements are crystalline solid with the high melting point due to the formation of the three-dimensional network of bond. Okay, except CO2, all the other dioxide molecules are forming the crystal form. Okay, as they are as its melting point is high due to the formation of the dimensional network of bonds. So after that, the pi bond or pi or d pi bond. Okay, multiple bond among the group 14 element. Carbon shows the pronounced ability for pi multiple bonds itself, like the graphite, and other elements, especially nitrogen, oxygen, they are the heavier elements shows the negligible tendency of this type of attachment. Okay, basically the some important points are there. That means the diamond having the sp3 hybridization, and the graphite having the sp2 hybridization. In the fullerene it is also the sp2 hybridization. Okay, so these are the general thing. I think the some questions comes from that kinds of hybridization topic also. Okay, this is very important for the all competitive examinations. So this is for today. I'll come with a new topic with a new concept for the tomorrow. Okay, till then keep watching and don't forget to subscribe. And if you have any doubt, please go on the comment box and comment it. If you have any doubt, then go on the comment box and please type your doubt, and I'll trying my best to solve it. Okay, till then keep watching, be safe and keep reading. Thank you.